So the idea here is to go through some of the aspects that makes a good proposal good and hopefully successful. And you will see that a lot of it is purely common sense, okay? But we were gonna have to go through them anyway, because surprisingly enough, common sense can be easily forgotten by anyone, okay? So the first thing, as Nando has mentioned before, is you have to make your science understandable, right? If the referee doesn't understand your science, it doesn't matter how many fancy words you use, they will not be excited about it, okay? If they are not excited about it, you've lost. And one important aspect of it is that, of course, the referee might not be an expert in your field. For example, if you submit a proposal for galaxies for the B category, of course, this will be people working on galaxies, but they will not be specific experts in that specific field that you're submitting a proposal. For example, I have submitted a proposal once about lenses in galaxies, but I had to explain what the galaxy lens is. This is not a gravitational lens, okay? Because I knew that a lot of experts in the whole world working on galaxies, they wouldn't know what a galaxy lens is. So I started from scratch explaining what a galaxy lens is and why I wanted to study galaxies. So you have to remember that you have to be very clear in your proposal and get to the point immediately, okay? If you don't get to the point immediately, if it takes a lot of time, a lot of reading for the referee to understand what you want to do, they might be bored before you get there, okay? So be explicit, do not assume that, do not assume that the panel will work out what you mean, okay? Normally, as Nando said, they have like 70 proposals to judge. So in that day, your proposal might be number 20 in the list. So they will not go in the literature and try to understand the field for you. This is your job actually to try to be explain to them as well as possible, as concise as possible, what is going on in your field. And as I said, so if the referee does not understand what you're saying, then you have lost already. Of course, you need to have a good idea, but you also need to explain it very clearly. And one way to explain very clearly is to, as Nando said before also, is to ask a question. So what is the question that you're trying to answer in your proposal? And what is it that we're gonna learn from your science, from the data that you are requesting? One useful way to do this in sometimes is to have a plot where you show what we learn, what we know with the current samples that are available, and you can show the same plot, how it is going to change after the observations you are proposing, or after the science you are proposing to do. You of course need to convince your peers, which are the OPC, that your idea is good and you lead somewhere else and it's worth being pursued. You have to really demonstrate that something is going to be learned. There is another important aspect which is more technical. You need to justify why you are requesting these telescope resources, how much time you are requesting, which instrument you are requesting. You need to really justify this. I'm going to go more about time and instrument later on, but there is also an important thing about the weather conditions that you are requesting. So the weather conditions you request in the proposal, for example, transparency and seeing, are the worst conditions with which you can do your science. Of course, everyone wants to have their observations done in the best conditions possible, right? Photometric conditions, 0.6 arcsecond seeing. But if you don't really need it, why are you going to ask for it, right? Because these conditions, they happen in Paranal, but they happen at a limited amount of time. So if you multiply this probability to the observability of your target and to many other constraints, of course, the chances that your observations are going to be executed gets lower and lower. So if you don't need 0.6 arcseconds in photometric conditions, don't ask for it. If you're doing low resolution spectroscopy of bright stars, maybe thin conditions or even thick conditions, and 1.2 arcsecond seeings is enough for your science. So don't ask for more than what you really need. And then, of course, in the proposal, there is a box where you need to demonstrate that your proposal is feasible. And you do this by using the exposure time calculators that are available on the internet in the ESO web pages for every instrument. And you can there check and verify that your proposal is feasible. And you have to explain this in the in the proposal in detail so that the instrument scientists in parallel can actually verify that your calculations are correct and that the proposal is actually feasible. So, of course, be aware that you're not the only applicant. Nando already mentioned that we have 3,500 individual co-Is applying for time. Other ways to make your science clear is to avoid jargon. Remember that expressions in your field may not be used by all other experts in the field, okay? Avoid acronyms, of course. What was epsilon added on is BA again, I don't even know. Age not, of course, may be understood by most people, but maybe omega prime, you need to explain what it is, okay? And if you need acronyms or special terms, then explain them, as I mentioned in the example of the galaxy lenses. Avoid complicated language, so use simple English. Okay, so most of us are not English native speakers, and most of the referees are also not English native speakers. But you must really do follow this recommendation here, which is to send your proposal to senior colleagues, hopefully native English speakers, so that they can check that your proposal is really written in good English. So this is just to remind you about what I just said. This is in the call for proposals, page 9. So the proposals should keep in mind the need for each OPC panel to cover a broad range of scientific areas, okay? So as a result, a particular proposal may not fall within the main area of expertise of the panelists. So proposals should make sure that the context of the project and its relevance for general astrophysics as well as any recent related result are emphasized in a way that can be understood by their peers regardless of their expertise, okay? So you don't really have to explain things as you would explain to your grandmother, but you have to take into account that the referees are not necessarily super experts in your field. The abstract is a very important paragraph. This is the one paragraph that you know is going to be read by everyone, so this paragraph has to be really well done. You have to summarize all the excitement you have about the science in that paragraph. And of course, during the process of writing your proposal, you may revisit the paragraph again and again to make it better and better. And the punchline of your science, of your proposal, has to be in the abstract. Okay, you don't want the referee to find the punchline in the third paragraph in the scientific justification. You want the referee to know what you want already in the abstract. Write a consistent proposal, okay? Have you selected the best suited instrument for your observations? So it happens very often that OPC panelists question whether you're really asking for the right proposal, if you really need that resolution, or if you're asking for something that will actually not help you answer the question you want to answer. And so you have to actually predict what kind of questions the panelists will make by reading your proposal. That's also why it's very important to give your proposal to other colleagues, because they can come up with these questions. So you have to predict these questions that will come through the minds of the referees and answer the questions already there in your proposal, why you're using that instrument and not another instrument. Also, we need to be consistent about the exposure times that you're using. We see more often than we wanted proposals in which the exposure time in the front page is different from the exposure time or the total time requested in the middle of the proposal, and this kind of inconsistencies, they will be catched by the referees, and then this of course displays against your case. Another thing related to exposure time is also you have to be sure that you are asking for the exposure time that you really need to achieve the signal that you really need to answer the question, because the referees will also be concerned about how much time you are asking. If the time you're asking is enough for the science case that you are proposing. And of course, as I said before, the exposure times, you can calculate them ETCs. So about figures and tables, it's very important that they clearly help the text. You don't put a figure just because it's pretty or because you think it's going to make the referees give you time by one reason or another, but they really have to help the referees understand what's your science case, what the question you want to answer. So the overheads is also a very important part of the proposal. You have to ask, so the total time you request is not only the exposure time, but it's the overhead. Okay, so because you have time, you need time to set the telescope to your object, to set the instrument. There's time for the detector to be read, and many other things. So this has to be accounted for in your proposal. And we have in the web for every instrument, or almost every instrument, many of the time that it takes for doing many of the different settings. Okay, so you can go through the web for your instrument, for example, force two here that he likes so much. We have the time it takes for every setting, and you have to add this to every observation that you are requesting. So the total time requested is not only the exposure time, but is the total execution time for your observations. You can also verify the overheads and the total execution times by using the phase 2 preparation tool. There's a new version of this tool. It's called P2 now, which very soon will be available for all instruments. So this is the best way actually to evaluate how much time you need, because you can put all the settings that you need for the instrument, the exposure time you need for every object, and it will calculate for you how much time you need, and then this is you can put in the proposal. And as I said before, exposure times, which is different from total execution time, you can derive with the exposure time calculator. So this is just an example here for UVs of the exposure time calculators. They are very simple to use, actually. There's a web interface where you need to just give some information about your targets, of your weather conditions and exposure times, and you can get, for example, the signal to noise you want. For some instruments, you can do the other way around. You can say, I want signal to noise of 100. How much time do I need? Or the other way around. I'm going to expose for 10 minutes. What signal to noise do I get? This, in the ETC, is also a way that you can verify if you really need dark night or a gray night. For example, you can play with the ETC and simulate observations during dark time, during bright time, during gray time, and see how the signal to noise changes. So if you don't see too much variation in the signal, then maybe you can apply for gray or even bright time. If you do see a lot of variation in the signal, then you can maybe you can add this to the justification. I need dark time because if I use gray time, my signal to noise drops by a factor of 5. So some helpful tips: take the instructions very seriously. So we find sometimes proposals which are not really providing all the information that is requested, and this of course plays against your proposal. And as Nando mentioned before, read the relevant parts of the COF proposal. So the COF proposals, every time there is just 3 sections, which are about 10 pages. I think it takes half an hour to read. And these 3 sections are the important changes for the period, important reminders, and future changes. This is the only thing you really have to read, and it takes half an hour. So you can read this every semester, there's no problem. If you really are in a rush, like most of us are, you can just use Control F, is a searchable PDF, and search for your instrument, for example, Symphony. You can see everything that is written about Symphony, everything that has changed about Symphony that you need to know. Okay. Things that you should not do. This is very important. Like a lot of people sometimes ask for time for observations of targets that are in the limit of the observability for that period. So for example, for period 102, which starts from October to March, if you ask time, if your object is observable only at the end of March, that means that there will be a lot of pressure in that array range at that time So the probability that the observations are going to be done, that your proposal is going to be scheduled, is low. So actually, you need to wait for the next period. Don't try it now, basically. The other thing is that don't include figures that are too small. The space is limited because, of course, referees have to read 70 pages, right? So the space is limited because we don't want you to put a lot of stuff, but a lot of people put a lot of stuff very, very small. And then the referees have to make an effort, which if it's the 20th proposal they are reading that day, they will just not be very happy. Don't submit your proposal at the last minute, okay? You can, there are two aspects about this. The first is that when you submit your LaTeX file to the ISO system, there will be a number of checks done here that verify if your proposal complies to the rules that we have for that period, right? This you cannot do on your system. So even if you run LaTeX on your computer and your proposal appears fine, that doesn't mean that you can actually submit when you really want to submit the proposal to us. So you can, before you have the proposal finished, a few days before the deadline, or even now, you can send the proposal to the system and just skip the last action, which is really to click in the submit button. But if you send the file, the LaTeX file, we can verify, the system will verify for you to say the LaTeX complies, it is fine, you can have a look at the PDF. And you can have a look at the PDF and look if it's fine. And then it will ask you, do you want to submit? So at this moment, if you don't want to submit yet, you just close the browser, it's fine. And then you can work a little bit in the size justification, for example. So then you can, you're sure that when you submit the proposal, it will go through the compliance checks. So Nando mentioned before the universal law of procrastination, and this is shown here in this plot. So this is time from the deadline. So we give 4 weeks, right? 30 days for people to submit proposals. This is in the last 10 days. So this is 1 day before the deadline. And we can even, no, this is 1 day. So we can zoom in the last 24 hours. 180 proposals in the last hour, okay? So of course, there are problems sometimes because people will try to submit their proposal in the last hour and they haven't verified the proposal really works. And sometimes, I think every period it happens, that people cannot really, they have the proposal ready, but for some stupid mistake that they didn't realize at the phase of compliance checks, the proposal does not get in. And they just, of course, they will not get the time. So try to avoid this last hour rush. Some other things you should not do. Submit more proposals that you can handle, because they will probably fall in the same panel, and the referees will start asking themselves if you really have the time to do all the science that you are proposing. And don't include QAs that without their explicit agreement, of course. You have to tick a box actually that you have talked to the QAs before you make the proposal submission. And don't falsify parameters to try to get around these compliance checks that we do. If you really need some combination of setups that we are not offering, you can contact OPPO, but you should do this several weeks before the deadline, and we will try to find a way that is more cleaner. If we can go about this, you can find a way for you to submit this proposal. Some things you should do, well, this was mentioned before a lot of times, read and understand the relevant parts of the call for proposals, especially if it's the first time that you're applying. But even if it's not the first time that you're applying, there are changes every period. Just do a Control F and look for the instrument you're applying time to. And another thing that you should do is, of course, check the GTO protection list that Nando mentioned before. So this is just the web page. For example, every period, there is a web page like this for all the GTO teams. So you simply click on these links. You have a list of targets that are protected by the GTO teams. So you can either in your proposal say that you checked and your target was not there. If your target was there, but you're observing a different setting, or if you think that your science case is different, you can just justify this in the proposal, and the OPC will take this into account. So just very quickly here, we mentioned before, right? Put your science into context. Don't forget the big picture, right? This is common sense again, but don't forget the big picture, because remember that no one in the panel might be as expert as you are actually in that topic. And be specific about the expected outcome of the project. What is the quantitative information that you want to get with this data? Which physical processes you are actually trying to explain or trying to understand better with the information, trying to constrain? And is this data going to be compared to any theoretical model? Or if there's no theoretical model, how do you go about this? With what you're going to compare the results that you're going to get from these observations? If you are resubmitting a proposal, and of course that a lot of the proposals are resubmissions, take into account the feedback that you received from the OPC the last time and try to answer it in your proposal. There is a box in the front page which is special remarks, where you can say this is a resubmission of the proposal. We are addressing the questions of the referee. You can already there say how did you address, or you can say in the scientific justification we are addressing this and that. Of course, this doesn't mean, even if you answer to all questions, all remarks by the OPC previously, that doesn't mean that your proposal will go through this time. But we recommend very much that you do this. And again, as I mentioned before, you have to justify very well the choice of telescope instrument, why you need that signal, the resolution, and something that comes very often is the sample size. So why you need 10 stars or not 100 to answer the question you're trying to answer. So be very clear about how the size of the sample was selected. Fill as accurately and completely as possible all required fields of the proposal form. This was also mentioned before. And also, as I said before, do a test submission to see if your proposal goes through the compliance checks. And once the time allocation is completed, once you receive the web letters back, try to understand, read and understand what's in the web letters, right? So, for example, if you don't understand why your proposal was not successful, or if you need more feedback, or if you think there was actually a technical mistake by the OPC, you can send an email to OPO, and this can be discussed, and we can ask for further feedback. This doesn't mean that your proposal is going to be reevaluated again, okay? If you didn't get the time, you didn't get the time. This is not going to be reevaluated, but we can ask for further feedback so you can improve your proposal next time. So this is just an example of the web letters. And in the web letters, you're going to receive not only the comments from the OPC panelists, but you're also going to receive a feasibility assessment by the instrument scientists in Paranal, and a scheduling comments from the OPO team that does the scheduling. So just to go through quickly from the timeline, for example, for every period, but now for period 102, release the calls for proposals on the 28th of February. We have 4 weeks basically to submit proposals, so deadline is coming in about 2 weeks. The proposal review takes time shortly after that, so you see that there is more or less a week after the end of the submission time when we are distributing the proposals to all the referees, and then they have about a month to review. We have then the OPC meeting at the end of May. We have about a month or a month and a half trying to put everything into the schedule for all telescopes. and there is a scheduled review meeting with the DG and the directors to approve the schedule. And for example, for period 102, the planned date for the release of the web letter, so when you will know that whether you got time or not, is 4th of July. For odd periods, this is just before Christmas, as I guess most of you know already. So as I said, a lot of people do resubmissions, and yes, we all have had proposals rejected, so that's why we do resubmit proposals. You should address the comments, as I mentioned, and one thing you need to understand that sometimes it will be clear that the OPC maybe didn't understand or didn't get a specific point in your proposal, but you have to ask yourself, is really their fault? Was it, or it was my fault that I didn't explain this well? And most of the times it's actually your fault. So be more explicit, more direct, more clear when you do a resubmission. If you're submitting actually the continuation of a program, you have to address the new goals. Why you are continuing with this same program? What are the new goals that you want to achieve? And why you need a bigger sample? This is, as I mentioned before, very important, the sample size. And what has changed since the last proposal? So what makes a proposal successful? Of course, there's no clear recipe. If there was a clear recipe, we would just put it on the web and we would not have to be here to discuss this. Of course, you need exciting science. You need something that will clearly produce progress in your field, in the understanding of some phenomenon. If you have a neat idea, just like a new way of approaching a question or addressing a question, or a new way to do some measurement, this will also be very helpful. And as I mentioned before, a clear language, like English, 5 minutes, okay. And also very important, cover all questions that somebody may have. And the story has to be consistent, of course, because the proposal has to be complete. You don't want the referee to be searching in the web for information that you didn't put in the proposal. So you have to be really consistent, and consistent between the different parts of the proposal as well. So just a few things before I complete. About the ESO archive, this was mentioned already before. It's a very rich source of data. So it's actually so rich that you should go first to the archive before you write a proposal, because maybe you don't even have to write a proposal. Maybe the observations you want are already there. Okay, so go and look for it. Or you can even go to the archive to justify why you need further observations. Okay. You also see abstracts of previous proposals available there. The data becomes public 1 year after they were taken from all telescopes. So it's a great way to keep in the competition, even if you don't get time. And it's very easy to use and to retrieve data. One way also to be more successful in proposals is actually to be more involved with these activities, right? So we have a users committee with representatives from all member states. You can contact them and you can ask them how you can get more involved in the process. You can get to know the organization better, maybe contact the ESO specialists in your instrument that you want to use. And of course, ESO provides a lot of workshops and conferences throughout the year that you can, of course, participate and get in touch with ESO in a more direct way. So the proposal that Nando wanted to submit before, if Earth moves or not, it can lead to a paper proving that Earth does not move. So this is just to say that asking the right questions, having a good idea, and getting telescope time sometimes is not sufficient, right? It's not only about marketing, about networking. You also have to have a good content in your proposal, scientific content in your proposal, and in the science you are doing. And with that, I will finish and leave you with time to apply for time.
Thank you, Dimitri. Questions? Yeah. Not really relevant, but still, the plot with about procrastination rate, was it made on data that was obtained for one period or for some period? Because there is a curious spike 16 hours before deadline. I'm curious where it came from.
I think Nando can answer this question better.
I think that is specific to period 91 or something. But yeah, so if you take the average of them, you always see what we call the German, am I allowed to say that? The German Swiss shoulder. And then you have the Chileans and the US that they start in advance. Now we have the Australian peak, the Australian effect, because they have to submit earlier. And then, so that spike now is not real, but the main behavior is very, very stable, which is very worrying.
Other question? Question from people online? No? Are you sure?
It's 5 in the morning in Australia.
Yeah. I forgot to mention that for those who need a password for the Wi-Fi, it's free and update.